Welcome to this deep dive. We're looking at a chapter on quadratic equations you shared.
Yep.
And the plan is, well, to get straight to the heart of it, what they are, how they're structured.
And how this source shows you to solve them. It's about pulling out the key info fast.
Exactly. And hopefully find that aha moment the source points towards.
Which is seeing how this one equation type pops up in, well, all sorts of places.
Okay, let's jump in. First thing, the definition. What makes an equation quadratic, according to this chapter?
The absolute core feature, it's got one unknown variable, and its highest power is specifically to a second-degree equation.
Power of 2. Got it. And the source makes a big deal about the standard form, x2 plus bx plus c equals 0. Why is that specific layout so important?
Well, that standard form, it's like the universal blueprint. Puts everything neatly on one side equal to 0. And critically A, the coefficient with $6.2 cannot be 0. That's non-negotiable in this form.
Ah, okay. And why is that?
Because if A was 0, poof, the 6 by 2 term is gone. You're left with bi of x plus c equals c.
Which is just a linear equation.
Exactly. Only one solution. You lose the whole quadratic part.
Right, that makes perfect sense. So the 602 is essential. The chapter also mentions the parts.
Yeah, it breaks it down. X222, that's the second power term. Then Beppe Osser, the first power term.
And c is just the constant, the absolute term.
Precisely. And a really key property highlighted is that every proper quadratic equation, in that standard form, not 0, it always has two solutions.
Always two. And the source calls them the roots of the equation.
Roots, that's the term.
That feels crucial. No matter the equation, you're hunting for two values that work.
Which leads us right into how the chapter says to actually find them. The main technique here, factorization.
Right, factorization. It seems like a clear process in the source. Step 1.
Get it into that standard form. Dax to 2 lars plus bx plus c plus dollars up, everything on the left, 0 on the right.
Okay, standard form first. Then what?
Then you factor the expression, the x to 2 lar plus bx plus c dollar part. Break it down into usually two simpler bits multiplied together.
Like dx plus e times all a plus g, something like that.
Exactly like that. The chapter gives examples, often involves finding numbers that multiply to give a times c but add up to b. It's a bit of a puzzle sometimes.
Okay, so you've got your factors, say, by $3 and 2x plus $1, and they multiply to equal 0. What's step 3?
This is where that core algebra rule comes in, the zero product property.
Ah, yes. If a product is 0,
then at least one of the things being multiplied must be 0. Has to be.
so you take each factor.
Each one separately, set it equal to 0.
So $3 becomes one equation.
And $2 plus $1 becomes the second.
And step 4 is just solving those two simple linear equations. Much easier.
That's it. $3 gives 6 by 3,003. That's one root.
And $2 plus $1 gives 612,
Your second root, found them using the factorization method from the source.
And this is where it gets interesting beyond just the math, right? The source connects us to actual problems.
Yeah, that's the really neat part described. It's not just abstract sixties. They show problems about finding unknown numbers.
Or calculating speeds, distance, time kind of things.
Exactly. Or figuring out costs, group sizes, even relationships between consecutive numbers. Things that, at first glance, don't look like x 2 plus bx plus c equals or dollars.
But you can translate them, take the word problem, and sort of build that quadratic equation from it.
Precisely. With a bit of algebraic setup, these real-world scenarios can often be modeled by that standard quadratic form.
And once it is in that form,
You can unleash the factorization method or other methods, find those two roots.
and those roots give you the answer to the original question about speed or cost or whatever it was.
Exactly. It connects the abstract math to tangible results.
Okay, so let's quickly recap this deep dive based on the source material. A quadratic equation, second degree, one variable.
Standard form is key. Axicum plus betas clepus plus c equals a and a is in 0.
It has distinct parts and always has two solutions.
Called roots.
And the main method shown here for finding them is standard form, factor the expression.
Then use the zero product property. Set each factor to 0, solve.
Simple steps, really. And it shows how this structure helps solve different kinds of problems laid out in the text.
Yeah, problems about numbers, speed, cost. It's presented as quite versatile.
It really highlights how getting comfortable with this one equation type and, say, factoring gives you a powerful tool.
Definitely. It's foundational.
Which brings us to a final thought. Inspired by those examples in the source, think about problems or questions you run into. Maybe at work, maybe just everyday life. Where there are unknown amounts, relationships between things. Could some of them, maybe unexpectedly, actually boil down to that simple x $2 plus base plus c you other dollar structure.
Waiting for those two roots to unlock the answer.
Exactly. Something to mull over.